This is 10-4 Solving Radical Equations Review. So we're going to do 5 examples in solving radical equations. Looking at example 1, we have the square root of c plus 10 equals 4. Our first step is to isolate the radical, or get it by itself. I'll put up here, by itself. Okay, well, that step 1 is already done for us. So, check that one off. Step 2, we need to square both sides. Okay, so I'm going to square both sides. In doing that to the left-hand side, that leaves me with c plus 10. And then 4 squared is going to be 16. Remember, anytime you square a radical, they're inverses of one another, so you're just left with whatever is under the radical. Now this is just a regular Algebra 1 problem. How do you solve for c? So this is step 3. Solve for the variable, the letter, the variable, same difference. Okay, so I'm going to do the opposite to get 10 to the other side. So I have c equals 6. Now, you do need to go back and check to make sure that this is going to work. For any of these, you must check. So plug in c equals 6 into the original problem and see if it works. Square root of 16 equals 4. 4 does equal 4. It works. So c equals 6 is my answer. Please make sure that you check. Alright, example 2. Now, I've got to follow these rules here that I have. Isolate the radical. Get it by itself. Well, in example 2, the radical is not by itself. It has a minus 4 with it. So what I want to do is I want to add 4 to both sides. So now I'm left with the square root of t equals 11. Now that the radical is by itself, I'm going to square both sides. And I get t equals 121. Square root squared, they are inverses of each other, so they cancel each other out, leaving you with just t on this side. So I need to plug in 121 in for t and check and make sure that I get the exact same thing that I started with. That they're balanced on both sides, I should say. Square root of 121 is 11, minus 4 equals 7. 11 minus 4 is 7. 7 equals 7. It works. So, t equals 121 is my answer. Remember, you're going to do these 3 steps every time. Let's go to example 3. Alright, in example 3, I do not have the radical by itself, so I'm going to add 2 to both sides first. And I get the square root of c minus 3 equals 6. Now that I've done that, I need to square both sides. That leaves me with c minus 3 here and 36 here. Add 3 to both sides. And c is going to be 39. Well, let's see if that's true. Let's check. Okay, plug in 39 for c into the original problem and start working out and doing the math. This would be 36. Square root of 36 minus 2 equals 4. The square root of 36 is 6 minus 2 equals 4. 4 equals 4. It works. So c equals 39 is my answer. Let's go to example 4. Now this one, the radical is isolated on one side by itself, so step 1 is done. I move straight to step 2, which is squaring both sides. When I square the left side, I get t plus 5. Now, squaring a binomial means this, FOIL. Okay, so I'm going to have to actually do this math and place my answer right here. It is not t squared plus 9. That is not a true statement. T plus 3 squared means t plus 3 times t plus 3. So when I FOIL, I get this. First, outer, inner, last. T times t, t times 3t, t times 3, then 3 times t, and then 3 times 3, which is 9. All right, combining middle terms here that are alike, I get this quadratic as my simplified form. Now, what you want to do when you get one like this and you have a quadratic, you want to move everything to the side with the square, to the t squared or whatever variable squared. So I'm going to minus t. So when I do that, it gets rid of it over here. And I'm t squared, 6t minus a t is now 5t plus 9. And I'm also going to minus the 5. I want to move everything over there to its like term. So now I have t squared plus 5t plus 4. Okay, so now I have a quadratic set equal to 0. So let's check to see, can I solve this through factoring? That's the best way to solve a quadratic. Break it down. The only factors of 4 that I can add and get 5 are 4 and 1. And then since the whole trinomial is addition, its factors will both be addition. And remember from chapter 8 and chapter 9 when we were doing these, to solve, you need to set each factor term equal to 0. So here t would be negative 4 and t plus 1 equal to 0. T would equal negative 1. Remember, I got that by doing the opposite on both sides. Okay, they cancel out here, and 0 minus 4 is negative 4, 0 minus 1 is negative 1. So I've got two solutions. Well, I do need to check to see if they work. So I'm going to come right here, and I'm going to check. I'm going to check by plugging in the first one, t equals negative 4. Let's see if that is a working solution, or is it what we call extraneous, meaning it's not valid, it does not work. I'm checking for these extraneous solutions. So I'm going to plug in negative 4 for t, and I'm going to plug in negative 4 plus 3 over here. I'm plugging it into the original equation. This would be the square root of 1 equals negative 1. The square root of 1 is 1 equals negative 1. That's not possible. So this one is what we would call an extraneous solution. It did not work. Let's check for t equals negative 1. So let's plug in negative 1 plus 5 equals negative 1 plus 3. Negative 1 plus 5 is 4, and this would give me 2. Square root of 4 is 2, and 2 does equal 2, so that one is the solution. Negative 4 is not. Last example. Again, I need to follow the steps. Isolate the radical first, and I get a minus 3 on both sides. So I have square root of 7r plus 2 equals 7 minus 3 is 4. Now I square both sides, and I get 7r plus 2 equals 16. And now it's just a regular problem from previous years of algebra. Just do the opposite to isolate the variable, to solve for the variable. 16 minus 2 is 14. Divide by 7 on both sides, and I get r equals 2. We do need to check and make sure that it works. So I'm going to say the square root of 7 times 2 plus 2 plus 3 on the outside equals 7. So this would be 7 times 2 is 14 plus 2 is 16 plus 3 equals 7. The square root of 16 is 4 plus 3 equals 7. 7 does equal 7. It does work, and r equals 2 is the solution. Please replay this video if you have questions, or pause it as you go along to make sure that you get these problems in your notes.